In this video, I'm going to talk about series circuit. What does that mean for series circuit? That means there's only one path that the current can flow. It's something like this. If we have our power source, resistor, one resistor, another one. So let's say we have three resistors. This is a series circuit. There's only one way that the current can flow. It basically everything is in one line. It's like a rope. You have one segment, the other segment, another one, and after the end they just connect to each other. So at the end they just connect to each other. There's only one cycle, one circle here. For example, if we have a circuit like this, we have our power source, resistor. Let's say there's only one resistor here. This is E, this is R. So basically there's only one resistor, so the total resistance is just R. Let's say E equals 30 volts, R equals 15 ohm. So based on Ohm's law, we can get the current I equal to E divided by R, which will give us 30 volts divided by 15 ohm. That will be 2 amps. The total power. So the total power will be P equal to E times I, which is 30 volts times 2 amps equals 60 watts. Same thing, the total power is equal to the power for R, because there's only one resistor here. PR equal to P equals 60 watts. We can also use a formula for power for resistor. That will be PR equal to I squared times R, or equal to E squared divided by R. These two formula will give us the same answer. So if we use this guy, I squared, which is 2 amps squared times R is 15 ohms. That will give us 60 watts. If we use this one, that will be 30 volts squared divided by 15 ohms. That will also give us 60 watts. Let's look at another example here. If we have two resistors in the circuit, this is E, this is R1, this is R2. So the current direction is from the positive side to the negative side. This is I. The total resistance will be R equal to R1 plus R2. Let's say E equal to 120 volts, R1 equal to 30 ohm, R2 equal to 90 ohm. So the total resistance will be 30 ohms plus 90 ohm. That will give us 120 ohm. And after we get the total resistance, we can get the total current. I equal to E divided by R, which is 120 volts divided by 120 ohms. That will give us 1 amps. Since it's a series circuit, the current are same everywhere. So basically I equal to I1 equal to I2. And after that we can get a voltage drop for R1, which is based on Ohm's law. V1 equal to I1 times R1 equals 1 amps times 30 ohm. That will give us 30 volts. So that is Ohm's law here. Let me change a different color. Ohm's law. So voltage drop for R2, that'll be V2 equals I2 R2 equal 1 amps times 90 ohm equal 90 volts. It's also Ohm's law. And next we can calculate the power. Let's say total power here. Total power will be P equal to E times I, which is 120 volts times 1 amps. That will give us 120 watts. And power for R1, P1 equals, we can use I1 squared times R1. That will give us 1 amp squared times R1 is 30 ohm, that is 30 watts. And power for R2, that'll be P2 equals I2 squared times R2. That will give us 1 amp squared times 90 ohm, that's 90 watts. So basically P equal to P1 plus P2. Okay, let's look at another example. What if we have 3 resistors, more than 3 resistors? So this is E, this is R1, this is R2, this is R3. Let's say E equal 120 volts, R1 equals 30 ohms, R2 equal 15 ohms, R3 also equal 15 ohms. Okay, let's solve this circuit. So we start from the total resistance. R equal to R1 plus R2 plus R3. This resistance is for series circuit. The total resistance is the sum of all the resistors. So R will be R1 plus R2 plus R3. That will give us 30 ohms plus 15 ohms plus 15 ohms. Total is 60 ohms. After we get the total resistance, we can get the total current, which is based on Ohm's law. EIR. This is a relationship between the EIR. E equals I times R. I equal to E divided by R. And R equal to E divided by I. So here, if we want the total current, I will be E divided by R, which is 120 volts divided by 60 ohm. That will be 2 amps. After that, we can get the total power. P equal I squared times R or E times I. So if we use the number here for E times I, that will be 120 volts times 2 amps, which is 240 watts. And we can get the voltage. So if we really want to get all the details, we need get the current. So the current same everywhere. That means I1 equal to I2 equal to I3 equals to I equal to 2 amps. And then we can get voltage drop for each resistor. Let's say voltage drop for R1, that will be I1. That will be I1. Let's say V1 equal to I1 times R1. That will be 2 amps times 30 ohm. that would be 60 watts. That's the voltage drop for R1. And voltage drop for R2. That'll be V2 equal to I2 times R2. That'll be 2 amps times 15 ohm. That will give us 30 volts. So basically these are all Ohm's law. Let me to have a different color here. Let's say we have blue. So these are Ohm's law. This is a very basic rule that we use when we solve the either series circuit or parallel circuit. And voltage drop for R3, that'll be V3 equal to I3 times R3 equal 2 amps times 15 ohm. That's also 30 volts. So E will be V1 plus V2 plus V3. That's KVL. Or another form is E minus V1 minus V2 minus V3 equal to 0. Kirchhoff voltage law. When we have a full circle, the voltage is 0. So when we look at the circuit, we have 120 here. There's 60 volts drop here, 30 volt drop here, another 30 volt drop here. So the total will be, if we have look at this circle, the total voltage is 0. And this is a direction for current. So we get the voltage drop. We can also calculate the power for each one. So power for R1, let's say P1, we can use the formula V1 squared divided by R1. We can also use I1 squared times R. We can use these both formulas. Let's say if we use the current, that would be 2 amp squared times 30 ohm. That will be 120 watts. And power for R2. P2, same thing, we can also use V2 squared divided by R2, also equal I2 squared times R2. So this is R2. So that will be 2 amps squared times 15 ohm. That will be 60 watts. Power for R3. P3 V3 squared divided by R3, also equal to I3 squared times R3. So that will be 2 amps squared times 15 ohm. That's also 60 watts. So usually when we look at the circuit, if we have another circuit, let's say we have 4 resistors. Let's say example 4. So for this one, I'm just going to talk about how we solve this circuit. We're looking for I1, I2, I3, I4, R, power P1, P2, P3, P4, and voltage drop V1, V2, V3, V4. So here, by looking at the circuit, series circuit, current are the same everywhere. And V or E equal V1 plus V2 plus V3 plus V4. If we have more, just keep adding. So when we start with solving the total resistance. The first step is solve the total resistance. Let's say R equal to R1 plus R2 plus R3 plus R4. And after that, we get the total current. or all the current. I equal to E divided by R. That's also equal to I1 equal to I2 equal to I3 equal to I4. So all the current are solved. And next one, we can get, by using Ohm's law, we can get a voltage drop for each resistor. So we can calculate by using V1 equal to I1 times R1, V2 equal to I2 times R2, V3 equal to I3 times R3, V4 equal to I4 times R4. So we get all the voltage drop. And of course, we can prove the KVL, the Kirchhoff voltage law, V equal to V1 plus V2 plus V3 plus V4. After that, we can get the power for it. Let's say total will be P equal to E times I. We can get the power for each one. Power for R1, power for R2. We can use P1 equal to V1 squared divided by R1. We can also use I squared times R1. Same thing, P2 equal to V2 squared divided by R2 equal to I squared or I2 squared times R2. And then we have the power for R3, power for R4. They all can use P3, P4 equal to V3 squared divided by R3 equal to I squared times R3 equal to V4 squared divided by R4 equal to I squared times R4. So far, we solve everything. We can solve the total power P equal to P1 plus P2 plus P3 plus P4. So they all relate to each other, or the total is depending on the resistors here. The total power will be the power for each one. So far, we get all the information from this circuit. We can get the current, we get the power, I1 P1, I2 P2, I3 P3, I4 P4. We also get the voltage drop. Let's see, this is V1, this is V2, V3, V4. That's all the information we can dig out from the series circuit. So let's review the step again. So we get the total resistance, we can get the total current. After that, by using Ohm's law, we can get voltage drop for each resistor. Then we can calculate the total power because we already have all the information. We have the current, we have the voltage. That's P equal V times I. That's the formula we're going to use. I hope you know how to solve the series circuits right now, and good luck in the future. Thank you for watching.